Welcome to AI Frontiers. On December 2nd, 2025, a single day yielded a staggering harvest of 160 new computer vision papers on the arXiv preprint server. This snapshot reveals a field evolving from simple recognition to deep understanding. 5 dominant themes point to the future of visual intelligence. Today's exploration provides a map to this frontier. The journey begins with an overview of why computer vision matters more than ever. Next, 5 major currents driving the discipline forward are examined. Paradigm shifts hidden within technical details are highlighted. The shared toolkit powering these breakthroughs is analyzed. A detailed look at 3 seminal prophetic works follows. Finally, the collective intelligence points toward future directions. Computer vision enables machines to derive meaningful information from images and videos. It serves as the foundational sensory layer for the broader AI revolution. Applications range from autonomous vehicles and medical diagnostics to creative tools. The field is no longer a niche subdomain but a massive, sprawling ecosystem. The 160 papers from a single day confirm its explosive growth and central role. The first dominant theme is a shift from generation to control. Research is moving beyond creating realistic images toward precise, physics-aware control. For example, SYNCTRACK 4D by LI aligns unsynchronized videos for perfect 4D reconstruction. Moregin by Bai et al. Uses code to ensure generated videos obey Newtonian laws. Poster Copilot by Wei et al. Automates professional-grade graphic design. Generation is maturing from a parlor trick into a disciplined tool for creation. The second theme focuses on understanding the building blocks of vision through representation, learning, and disentanglement. This involves teaching models to decompose the visual world into its fundamental factors of variation. It is analogous to a mechanic identifying separate sounds within an engine. Disentangle Former by Liao et al. Explicitly decouples spatial information from channel information. Another approach by Swarnali et al. Partitions latent representations without manual labels. The goal is to build clean, interpretable representations for robust and generalizable intelligence. The third theme forms the pragmatic backbone of the field: efficiency, compression, and deployment. This drive focuses on shrinking computational behemoths so they can operate in the real world. NVRC Lite by Quan et al. Enables neural video compression for edge devices. Pyramid Sparse Attention by Li et al. Drastically cuts computation in video models without losing critical details. Other work involves training super-resolution models directly on compressed JPEG data. This theme represents the essential bridge from lab prototype to technology in your pocket or car. The fourth theme acts as the field's immune system: robustness, reliability, and safety. This involves critical self-examination of where and why models break under real-world conditions. Benchmarks like Adversarial Anatomy Bench test medical vision language models on rare anatomical variants. Research studies model calibration in federated learning settings for models like CLIP. Deepfake detection is improved by training on synthetically generated kinematic inconsistencies. Accuracy on a clean benchmark is recognized as just the first step toward earning trust. The fifth and final theme is the drive toward unified and multimodal understanding, breaking down walls between tasks. The frontier is leaning towards generalist AI systems. Unimo by Pang et al. Is a single autoregressive model that can both generate 2D human videos and understand or infer 3D human motions. Unilight by Zhang et al. Creates a joint latent space that unifies lighting information from text, images, and professional 3D environment maps. These systems aim to reason holistically across different data types, much like the human brain integrates sight, sound, and contexts. Several key findings across the papers represent potential paradigm shifts. Mind-to-Face by Zhong et al. Decodes non-invasive EEG signals into high-fidelity, dynamic 3D facial expressions. Analysis reveals that standard feed-forward models can develop implicit geometric reasoning without explicit training. SimFlow by Zhao et al. Finds a path to highly efficient and simple normalizing flows. Perhaps most striking is the challenge to a core dogma. Single-life learning shows that training on one person's 30-hour egocentric video can yield geometric representations as transferable as training on diverse web data. These findings are powered by a shared toolkit of advanced methodologies. Transformer architectures remain the workhorse, but with specialized attention mechanisms for efficiency. Diffusion models are increasingly integrated with real-world physics processes. Neural field and 3D Gaussian representations have revolutionized 3D reconstruction and novel view synthesis. The retrieval-augmented generation paradigm is successfully migrating from language models into the visual domain. Finally, reinforcement learning from human or AI feedback is a standard tool for aligning models with complex, subjective goals. A seminal paper by Khalid et al. Presents a retrieval-augmented generation approach to extracting algorithmic logic from neural networks. It automates the extraction of neural network modules from sprawling PyTorch codebases. Its core innovation is scope-aware dependency resolution, which ensures extracted code snippets become compilable, standalone modules. A validated gated promotion step dynamically tests and guarantees every module actually works. Applied to 19 repositories, it successfully validated 941 compilable modules. Remarkably, it supplied approximately 72% of all novel network structures in the Lemur architecture dataset. Another groundbreaking paper is Xiong et al.'s Mind-to-Face, which decodes EEG into photorealistic avatar synthesis. This work establishes the first framework for decoding non-invasive EEG signals into high-fidelity dynamic 3D facial expressions. It uses a hybrid CNN transformer encoder to process the complex neural signal. The model outputs a dense 3D position map representing over 65,000 vertices of a personalized face model. It captures subject-specific, nuanced emotional geometry, transcending basic emotion classification. This enables new communication channels for individuals with locked-in syndrome and allows for authentic, camera-free avatars in virtual reality. The third selected paper is Li et al.'s SYNCTRACK4D, which tackles 4D reconstruction from unsynchronized handheld videos. It achieves high-fidelity reconstruction from chaotic, in-the-wild video sets without prior models. The method uses dense 4D feature tracks and a fused Gromov-Wasserstein optimal transport approach for cross-video matching. A global frame-level alignment maximizes motion overlap between videos to achieve synchronization. Subframe precision is attained via a novel multi-video 4D Gaussian splatting process, built on a motion spline. This solves the deeply coupled problems of temporal synchronization and spatial reconstruction jointly in a completely general setting. The collective intelligence of these papers points clearly toward future research directions. A major trend is neuro-symbolic integration, combining the pattern recognition of neural networks with the logical rules of symbolic AI. Another is the development of foundation levels for embodied agents, where vision serves as the active perceptual core for robots and autonomous systems. The convergence of efficiency and privacy research points towards personalized, on-device AI, distributed adaptive intelligence. Significant hurdles remain, including overcoming the efficiency wall despite innovations, and solving the critical safety and alignment problem as systems become more autonomous. This presentation was synthesized using the GPT DeepSeek model for content creation. Text-to-speech synthesis was prepared using Deepgram for audio delivery. Image generation concepts were designed for Stable Diffusion. A human expert reviewed all synthesized content for technical accuracy. It is important to note that some oversights may exist despite this review. All references to specific research papers are derived from the provided summaries. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.